Hi friends, you are welcome back to another interesting question. We are to calculate the blue area, that is this triangle RST. We see this quadrilateral is a square-shaped quadrilateral and this is a semicircle. We see this line passes through this point, which is the point where line RT touched the semicircle. This here is a right angle and this is also a right angle. Line PV has its length to be 24 units. So how can we solve this? How can we calculate the area of this triangle RST? Well, it is very simple. This quadrilateral is a square-shaped quadrilateral. One of the properties of a square-shaped quadrilateral is that all four of its sides are equal in length. That is, this side, this, and this are congruent. So if you assume this to be y, this side, this, and this must also be y. Another property of a square is that all its angles are right angles, meaning this angle and this are also right angles. Okay, now look at this triangle RST. It is a right angle triangle. To calculate its area, we can use the formula 1/2 base times height. In the case of a right angle triangle, the perpendicular sides are the base and the height. So here, if we let this be the base, this must be the height, say h. So base equal to y, height equal to h. Substitute here. Now area of triangle RST equal to 1/2 times y times h, which is 1/2 hy. So what are the values of h and y? We don't know, but come to this line SV. Its length is y, but it is divided into this segment ST and this TV. So since this ST has its length to be h, this must be y minus h. Now since this is a semicircle, that is half a cycle, we draw out the other semicircle. This line PV is a diameter of the circle and it is perpendicular to this line SV, or vice versa. From the circle theory, there is a rule that the tangent of a circle is perpendicular to its radius through point of contact. So based on that rule, since this is a diameter which is 2 radii and it is perpendicular to this line SV is a tangent to the circle. We see this line RT also touched the circle at this point. Therefore, it is also a tangent to the circle. We can say this tangent and this are drawn to this circle from this same external point. From the circle theory, there is a rule that if two tangents are drawn to a circle from the same external point, their segments are equal. That is, this segment and this are equal. So since this has its length to be y minus h, this must also be y minus h. Come to this triangle. Since it is a right angle triangle and we have the layer of this side to be y, while this is h, this side RT, which obviously is the hypotenuse, is divided into two segments, this and this, where we have this to be y minus h. Assume this to be E. Use the Pythagorean theorem, which states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse, its length is a summation of this E and this y minus h. So applying the Pythagorean theorem, E plus y minus h all squared equal to y squared plus h squared. E plus y minus h all squared is E plus y minus h multiplied by E plus y minus h, which is E times E plus y minus h plus y times E plus y minus h times E plus y minus h. E times E plus Y minus H is E squared plus EY minus EH. Y times E plus Y minus H is EY plus Y squared minus HY. Minus H times E plus Y minus H is minus EH minus HY plus H squared. Minus EH is minus 2EH. Minus HY minus HY is minus 2HY. This Y squared will eliminate this on the right. This H squared will also eliminate this on the left. So E squared plus 2EY minus 2EH minus 2HY equal to 0. Here minus 2EH minus 2HY. Minus 2H can be factored out. So it is minus 2H into bracket E plus Y. Take minus 2H into bracket E plus Y to the left. So E squared plus 2EY equal to 2H into bracket E plus Y. Keep this equation aside for now. Come to this triangle. It is a right angle triangle. And we see this side and this are congruent. That is, it is an isosceles right angle triangle. The angles of an isosceles right angle triangle are 90 degrees, 45 degrees, and 45 degrees. So since this is 90 degrees, this and this each must be 45 degrees. But this whole angle is a right angle. So since this part is 45 degrees, this must be 90 degrees minus 45 degrees, which is 45 degrees. Come back to this triangle. We see this line bisects this angle of it. Therefore, it is an angle bisector of the triangle. There is the angle bisector rule that states the angle bisector of a triangle divide the opposite sides into two segments that are in the same proportion as the other two sides. That is, this segment and this are in the same proportion as this side is to this side. So E over Y minus H equal to Y over H. Cross multiply. Here E times H is EH, while here Y minus H multiplied by Y is Y squared minus HY. So EH equal to Y squared minus HY. Take the transpose of minus HY to the left. So EH plus HY equal to Y squared. Here we factor out H. So it is H into bracket E plus Y equal to Y squared. Now come to this equation. Replace this H into bracket E plus Y with Y squared. So E squared plus 2EY equal to 2Y squared. Here H into bracket E plus Y equal to Y squared. We make H the subject of the formula by dividing through by E plus H. Here E plus Y cancels E plus Y. So H equal to Y squared over E plus Y. Come back here. Since this angle is a right angle and we have this part of it to be 45 degrees, this must also be 45 degrees. This line is a diameter of the circle and its length is 24. From the center of the circle to this point on the circumference is a radius, which is half the diameter. 1/2 times 24 is 12 units. From the center to this point of contact of tangent RT is also a radius, which is 12 units in length. Recall the rule that the tangent of a circle is perpendicular to its radius through point of contact. This line RT is a tangent and this is a radius. Therefore, through this point, they are perpendicular. Now look at this quadrilateral. This angle is a right angle and this is also a right angle. They are opposite to each other. 90 degrees plus 90 degrees is 180 degrees. This is a property of a cyclic quadrilateral. The opposite angles are supplementary. So this is a cyclic quadrilateral, meaning all four of its vertices lie on the circumference of the same cycle. Draw out the cycle. Now draw a straight line that connects this point and this. Look at this angle and this. They both are subtended by this same arc to the circumference of this cycle. Hence, they are congruent. So since this is 45 degrees, this must also be 45 degrees. Now look at this triangle. It is a right angle triangle, and this angle is 45 degrees. Based on the rule that the summation of angles in a triangle is 180 degrees, this must be 180 minus 90 degrees minus 45 degrees, which is 45 degrees. That makes the triangle an isosceles right angle triangle. Perpendicular sides of an isosceles right angle triangle are congruent. That is, this side and this are congruent. So since this is 12 and this is E, that means E equal to 12. Come here, substitute E equal to 12. So 12 squared plus 2 times 12 times y equal to 2y squared. And here, h equal to y squared over 12 plus y. Back to this equation, 12 squared is 144. 144 is the same as 2 times 72. Here, 12 times y is 12y. From here, we can factor out 2. So it is 2 into bracket 72 plus 12y, which equal to 2y squared. This 2 eliminates this 2. So 72 plus 12y equal to y squared. Take 12y and 72 to the left. So y squared minus 12y minus 72 equal to 0. This is a quadratic equation. We can use a quadratic equation formula by which for any equation in the form ax squared plus bx plus c equal to 0, x equal to minus b plus or minus root of b squared minus 4ac all over 2a. Let x equal to y. Substitute it here and here. Now compare this equation to this. We'll obtain a equal to 1, b equal to minus 12, and c equal to minus 72. Substitute it here. Now y equal to minus into bracket minus 12 plus or minus root of minus 12 all squared minus 4 times 1 times minus 72 all over 2 times 1. Minus into bracket minus 12 is plus 12. Minus 12 all squared is 144. Minus 4 times 1 times minus 72 is plus 288. 144 plus 288 is 432. Square root of 432 is 12 root 3. From 12 plus or minus 12 root 3, we can factor out 2. So it is 2 into bracket 6 plus or minus 6 root 3. 2 times 1 is 2. This 2 eliminates this 2. So y equal to 6 plus or minus 6 root 3. Therefore, either y equal to 6 plus 6 root 3 or y equal to 6 minus 6 root 3. Root 3 is greater than 1. If you simplify 6 minus 6 root 3, you'll get a negative number. Y is the length of this side. It can't be a negative number. We discard it. Therefore, y equal to 6 plus 6 root 3. Come here, substitute it. Now h equal to 6 plus 6 root 3 all squared all over 12 plus 6 plus 6 root 3. 12 plus 6 is 18. 6 plus 6 root 3 all squared, if you expand, is 144 plus 72 root 3. Now 144 plus 72 root 3 all over 18 plus 6 root 3 multiplied by 18 minus 6 root 3 all over 18 minus 6 root 3. This bracket multiplied by this bracket will give 1296 plus 432 root 3. While this 18 plus 6 root 3 multiplied by this, if you simplify, is 216. 432 is 216 times 2. And 1296 is 216 times 6. From here, we can factor out 216. So it is 216 into bracket 6 plus 2 root 3. This 216 cancels this 216. So h equal to 6 plus 2 root 3. We found y equal to 6 plus 6 root 3 and h equal to 6 plus 2 root 3. Substitute it here. 1 over 2 times 6 plus 2 root 3 is 3 plus root 3. Multiply it by 6 plus 6 root 3. It is 36 plus 24 root 3. So therefore, blue area equal to 36 plus 24 root 3.